In this section, you're going to learn how to multiply and divide radical expressions. And one of the main things you're going to learn today is how to simplify. So if you want to kind of maybe put that word on there, you're going to have to learn how to simplify these. But before you get started, you should remember a couple of your perfect squares. Take a moment and pause the video if you don't know them, or write them down, or if you have your sheet, or even your 6-1 notes, okay? Some perfect squares, 4, 9, 16, 25, all of those can be found on that list that I gave you. And don't forget, those do go on. A couple of perfect cubes we use. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. Those are just some to remember. Take a moment and pause if you need to copy those down. Alright, now this little box down here talks about how you can multiply things together. And I kind of think it's confusing with all the letters, so let me give you an example of something that would work. They're saying pretend you have the cube root of 2. And you see that that's being multiplied by the cube root of 4. You can go ahead and put those together under a single cube root, and they will become the cube root of 2 times 4, which would be the cube root of 8. That's what they're trying to explain to you in that little box. But on the other hand, let's say that you have the square root of 2 times the cube root of 4. See the difference? You can't multiply those together. Those are done. Why are they done? Because they have different indexes. Okay? Let's try to apply this, and also let's try to simplify on problem 1. The question is, can you simplify the following products? Look at part A. Do you see how this one has an index of 3, and then this one has an index of 2? Let's circle them. That might be better. Can you see how the one has an index of 3 and the other one has an index of 2? That means that one's done. You cannot simplify this anymore. So we're going to put no. I like to actually write the word done because it's as simplified as it gets. Look at the next one. You have the cube root of negative 4. Okay, look, you got a negative cube. And you have the cube root of 2. Those do match, so you're allowed to do the cube root. What's negative 4 times 2? Negative 8. Now I want you to take a pause and look at this cube. Ask yourself, is there any cube of negative 8? Cube root, maybe. The answer is yes. Okay? This answer is going to be negative 2 because negative 2 times negative 2 times negative 2 is negative 8. Let's move on. Can you simplify the following? Look at the indexes. We've got a 4 and a 5. The answer is no. These are done. Look at the following. You have 5 and 5. This one's a yes. We're going to multiply them together, so we'll keep the 5. Negative 5 times negative 2 is 10. Now you ask yourself, are there any fifth roots in 10? The answer is definitely no. Okay? That's done. Let's go to problem 2 and try simplifying even more. So we have the cube root of 54 x to the 5th. Now what I want you to do is I want you to just for a second picture 54. We are looking for cubes on this problem. Write that down. Now think of cubes in 54. Alright, I'm going to go to my list. Do any of these numbers go into 54? Definitely. 27, right? So here's what you're going to do. You're going to make this, ready, real small. 27 times, well, 27 times what? 27 times 2 makes 54. Alright, now let's take a look at what our simplified answer is going to be. We have the cube root. 27 comes down out in front. What is the cube root of 27? 3 with a 2 left inside. Now take a look at x. We did do this in the previous video. I'm going to move 3 over. I want you to take 5 and divide it by 3. Okay? 5 divided by 3 is 1 single x with 2 left over. Now if you're wondering how I did that, okay, if you have x to the 5th, the question is how many groups of 3? Okay, how many groups of 3? It has 1 group with 2 left over. So here's our 1 group with 2 left over. Let's try it again. This time again we are going to look at cube roots. Go to your list. Do any of these cubes go into 128? So we are looking for cubes in 128. Hopefully you're going to understand that 64 times 2 works because 64 is a cube. Now let's rewrite down here. What is the cube root of 64? The cube root of 64 is 4 with 2 left over. Now take a look at x to the 7th. How many groups of 3 are in x to the 7th? So I'm going to write it down. How many groups of 3 are in x to the 7th? Well, the answer to that is there are 2 groups of 3 with 1 left over. So here's how we write that. There are 2 groups of 3 with 1 left over. Problem 3, simplifying a product. When you come to these kind of problems, the first thing you need to look is at the index. These each have a hidden index of 2. If that's the case, you can smush the problems together. This will be the square root of, well, 72 times 10 is 720. X cubed and x to the 1st is x to the 4th. Y squared and y to the 3rd is y to the 5th. Now we have a problem just like we did in problem 2. This time we are looking for squares in 720. Well, I'm going to flip back to my front page. What is the biggest square inside of 720? If you need to, pull out your old chart. Okay? In this case, the biggest square in 720, and you'd have to pull out your old chart and know how to do this, is 144 times 5. Now why would I pick 144? Because 144 can come out. The square root of 144 is 12. Let's talk about our leftovers. If I pull a 12 out, I have to leave a 5 in. Now let's do x to the 4th. Remember, this is a hidden 2. How many groups of 2 are in x to the 4th? 2 groups. How many groups are in y to the 5th? There are 2 groups with 1 left over. If you need to picture it this way, here you go. You have x, 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 x. 2 groups can get pulled out. That's why we have 2 groups on the outside. Now let's talk about the y's. 1, 2, 3, 4, 5. The question is how many groups of 2? 1. 2 groups that you can pull out. Here's the 2. 2 groups you can pull out with 1 left over inside. So if it helps you visualize that way, that's what you're looking for. Got it, number 3. Look at the indexes. Can you even multiply them? Yes, you can. They each have a hidden index of 2. So, you do 45 times 35 is 1,575. How many x's are you going to have? You will have x to the 6th, because you have 1, 2, 3, 4, 5, 6. And you have y to the 1, 2, 3, 4, 5, 6, 7. Now you really have to think of a perfect square that goes into 1,575. If you go back to your old list, you would start pretty high and just start dividing until you can figure one out. You need to be able to figure this out on your own. You should end up with 225 times 7. So you pull out the square root of 225, which is 15. What's left inside? The 7. Now you have x to the 6th. 1, 2, 3, 4, 5, 6. How many groups of 2 can you pull out? 1, 2, 3. Now you have y to the 7th. 1, 2, 3, 4, 5, 6, 7. How many groups of 2 can you pull out? 1, 2, 3. But there is 1 left over. Problem 4 is about dividing. Now when you come to this one, again the indexes have to match. So 2 and 2, they match. What you want to do first is you want to go ahead and write this down. Step 1. See if you can divide. Okay? If it makes it easy, divide before you do anything else. So let's look at problem 1. Could you divide these as they are? Absolutely. You could write it as one very large square root, 18x to the 5th, 2x to the 3rd. You could definitely write it like that and then just reduce. 18 divided by 2 is 9. X to the 5th and x to the 3rd becomes x squared. Because it's 5 minus 3. Like, there's 5 up here that cancel with 3 down here, so you get x to the 2 left over. Now look how much better this is. You know the square root of 9, don't you? The square root of 9 is 3, with nothing left over. And how many groups of 2 are in x squared? There's a single group. So that one's done, just becoming. In problem 4, got it, or problem 4 part B, we're going to do the same thing. Check if the indexes match. They do. So we're going to see, can I do 162 divided by 3? Well, 162 divided by 3 is 54. So I'm going to have 54 on the inside. Now I did this whole problem and I made a really big mistake. I forgot to keep my index of 3. So don't forget to carry your index over. Alright, now let's look at the y's. Y to the 5th and y squared, how many are left over when you divide them out? Y cubed. Now what we're going to do is, since we have the cube root, we're going to look at cubes in 54. So let's go to the beginning of the class. Look at these numbers, your cubes. What of these numbers goes into 54? I really hope you say 27. So you're going to do 27 times what? 2 is 54. 27 comes out, and you get a 3 with the cube root. Leave a little space in case we'll take some variables out. 3 and the cube root. What's left over? 2. Now think about your y's. I'm pulling out groups of 3. So I have y, y, y. How many groups of 3? I can pull out a single group with none left over. Let's try the got it. Can you divide? Well, 50 divided by 2 is 25. So the indexes match. I'm going to make this 25 instead. I'm going to keep my index of a hidden 2. X to the 6th and x to the 4th makes x squared. Now this is nice because I know you know the square root of 25 is just 5. And how many groups of 2 can I pull out? a single group with none left over. Part B. Can you simplify the 1 in 4a? Okay, way up here. Way up here. Could you have simplified that by first simplifying 18 and 18x to the 5th and 2x to the 3rd? The answer is yes, but it would be very difficult. So my answer is don't do it. If it divides, divide it.